Good evening, students. Welcome to Students Accuracy and Demand Science class. Today, before I start, yes, an important topic. I would start with thanks to all my subscribers, those who have subscribed all those videos so far I have uploaded. A big thanks to them, and even I would request all my subscribers to please share my video as much as possible, as more as possible, so that I can expect more subscribers. You know, students, why I am asking for this subscription of my channel? Because this inspires me. It tells me that how much you people are liking me and my effort which I am trying. One of them is now today's topic. This topic again, I have tried it in a different manner. I have tried a new experiment with the help of various other activities and videos. I am trying to make this video, upload this video. I would expect that you would like this, you would enjoy this, and the topic which we are going to discuss. As usual, please press the like button if you like it. Press the bell icon and share this video. And please see this video from the very beginning to the end, because today's topic is also a very important topic, because the topic is nothing else other than right-angled triangle, that is Pythagoras theorem. Okay, enjoy the video. Hello students. Now, did you see the history of Pythagoras? I would recommend again you please go back and pause the video and note down some information. The video is very informative about the history of Pythagoras, isn't it? So now, actually, I'm trying to make it. This is the way, one of the ways in which I'm trying to experiment my videos. Some more examples also are yet to come in the same video. Let me first start with my part of explanation. Then after explaining this total Pythagoras theorem, some experiments will come, and even I would try to put down a model for you through which you would be able to understand, and you can create also for your school's project this particular model, and you can apply it in your exhibitions, in your school's exhibition. I hope that you would be appreciated if you do this model or do this type of experiments in your exhibitions. You can apply your own brains, you can apply your own innovative thoughts You can modify it. As an example, I am just giving it to you so that the idea enters into your brain and you can apply your own method and create something new. And that is mathematics. That exercise that enables you exercise your brain. Okay, now see Pythagoras, how important formula he has given us. This Pythagoras theorem which we are going to learn now will be applicable in various other branches of mathematics. See, it might be, as an example I'm telling you, it is used, not might be, it is used in mensuration, it is used in trigonometry, it is used in various other topics in geometry. Okay, so Pythagoras has helped us in immense methods, in immense topics, in immense subjects. So it is very important topic and very interesting also. Let us start. Keeping everything aside, we all know who was Pythagoras. So now let us start what he gave us, the Pythagoras theorem. See, Pythagoras theorem is totally based upon a right angled triangle, as I told earlier. Right angled triangle, we all know, this is a right angled triangle. Suppose this is the triangle, and a right angled triangle is that triangle in which at least one angle is of 90 degree. See, here if it is 90 degree, then this triangle A, B and C, this triangle ABC is a right angled triangle, and in this right angled triangle, this is called as perpendicular. We can denote it as P. This can be called as base, denoted as B, and this one is called as hypotenuse, denoted as H. Okay, students. Now, how to understand, sir, which one is hypotenuse, which one is perpendicular, and which one is base? See, base and perpendicular can be, base and perpendicular can be interchanged. Base and perpendicular can be interchanged, but hypotenuse will remain constant. Whatever the direction you turn the triangle, suppose the triangle is like this. It is right angle from here at C, and suppose this is A and this is B. See now, it was B, so let this be A and let this be B. Now see, the base was BC here in this triangle. Here AC becomes the base, and here BC becomes the perpendicular, but BC initially was base here and AC was the perpendicular in this diagram. Here BC instead of being the base becomes the perpendicular, and AC instead of being the perpendicular becomes the base. So I told that base and perpendicular may be interchanged, but see, hypotenuse was AB in this diagram. Here still it remains the hypotenuse in this diagram also. Understood? So therefore, sir, how to understand which one is the hypotenuse and which one is the perpendicular and which one is the base? Perpendicular base is not important. Most important is to recognize which one is the hypotenuse. By seeing two things, we can understand by the hypotenuse has two properties. Number one, it is the longest side of the triangle. Hypotenuse is the longest side of the triangle. Suppose the triangle is of 3 centimeter, 4 centimeter and 5 centimeter. Obviously this 5 centimeter is the highest of these three. So this 5 centimeter would be the hypotenuse in this diagram, in this triangle. So What is hypotenuse? The longest side of this triangle is the hypotenuse. Now second property is that the side opposite to the right angle. See, right angle is here at C. Which side is opposite to right angle? Side AB. Here also, see, side AB. So the side that is opposite to the right angle is always called as the hypotenuse. So the most important two properties of hypotenuse we have understood. One, the longest side of the triangle. Two, the side opposite to the right angle is called as the hypotenuse. Okay, students? So here we have understood the parts of the right angled triangle that would be utilized, or that is utilized by Pythagoras in his theorem. Okay, now what is his theorem actually? His theorem is Formula 1. He said hypotenuse square, means square of the longest side, is equal to the sum of the square of the other two sides. What are the other two sides? If longest side is the hypotenuse, what is the other two sides? The perpendicular and the base, or the perpendicular and the base, as here we saw, base and perpendicular. Okay, so height square is equal to perpendicular square plus base square. This is the original formula he has given. Sir, how? Through activities I am going to show in your next videos. Means in this video only, after I finish my part explanation, then I will be putting some more videos in this particular experiments. Means more experiments I will be giving you here only in this video. They are coming. Now let me finish this part. Now number 2, let us find p square. Now see, as per simple equation, p square means b square will go to the left hand side. It is in the right hand side. Now it goes to that side, means it will become minus b square. So 8 square minus b square. Next, number 3, instead of p square, if it is b square, let it be. Obviously it will become b square, means this b square we are going to find. P square will come this side. So 8 square minus p square. That is the formula. Now, suppose we want to find the height here. From here we can derive h square is not intended. We want only h, because this is not h square. This is h, means only the length. We don't want the square of the length. We want the hypotenuse only. So in that case, h is equal to root over p square plus b square. Root over p square plus b square. Similarly, instead of finding the perpendicular square, we need to find only the length of AC, means only the length of the perpendicular. Then p is equal to root over h square minus b square. And similarly, b square, from b square means we don't want to find the square of the base, we want the base, length of the base. In that case, b is equal to root over h square minus b square. That's it. That is Pythagoras theorem. Okay, students, this Pythagoras theorem in practical life, for example, is applicable. Say suppose, I'm not mentioning the names of the other branches of mathematics that applies Pythagoras. In immense branches of mathematics, this Pythagoras theorem is applicable. As an example, let me give you an example. Suppose I am standing here and I know the length of this wall to the wall opposite me. I know this length. And I know the height of this wall. But I want to know the distance from this edge to the bottom edge of that wall. That means, see, it has formed a triangle. The base, that is the floor is one line to me, and another line, the wall is another line, and from the top to the diagonal, the bottom of that wall, top of this wall to the bottom of that wall, it will become the longest side, because this is 90 degree here at the bottom, at my foot, 90 degree. So the side opposite to 90 degree is this diagonal from the top of this wall to the bottom of that wall. So that is the longest side, that is the hypotenuse. So we can find out this distance. Another example. Suppose I am standing here and I want to find the height of the wall. I know this distance, I know how much angle I am looking at the top of the wall. Here, trigonometry. Those who are in class 10, they will be able to understand. Angle of elevation. I am at the angle at which I am looking at the top of the tree or the mountain or the tower or the building. This angle I know. The length between me and the foot of the tower or the tree or the whatever it is, I know. I want to know the height of that. Again, here it will be applicable. In trigonometry also, some people have curly brown hair turned permanently black. Many of you know, isn't it? Yeah, I know. It's a very common thing. Anyways, regarding this, I'll be making another video. It will be an interesting thing. So, it's a question mark. So when it's going to come, it will come. Don't worry. सबर का फल मीठा होता है, and I'll be coming with that. Some people have curly brown hair turned permanently black. Again, this is a part of trigonometry that I will come. Pythagoras is the most important topic now, which we are going to discuss, which we have so far. I have finished explaining. Now, let the experiments come in front of you and you will enjoy it. I hope so. But anyways, no more talking. Please first see the video.
In the 6th century BC, a Greek philosopher by the name of Pythagoras claimed that in any right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Now we're going to check to make sure that Pythagoras was right in this. We're using a 3, 4, 5 triangle here, but you can use any right-angled triangle. It works the same for all. You can use meters, you can use inches, you can use miles, you can use kilometers, you can use cubits. Doesn't matter what measurement you use, it works out right. But let's check it out and see. Well, there we are. He was right. 9 squares and 16 squares equals 25 squares, and they all fit into there.
Hi guys, today we have a model on Pythagoras theorem. As you can see, there is a D and a lift over here. When you increase the height of the lift, the length of the hypotenuse will also increase. When you decrease the height of the lift, the hypotenuse will also decrease. If you want to make the same model, it is quite easy to do so. Your book, I am telling you guys, take a photocopy. Don't cut from your book. Then paste it on your mount board. Then take a shoe box and whatever box you like to make this lift. To make this small box, use a gift box and whatever a small box you like to do and whatever you want to make. Then to make a machine which you will use to lift upward and downward this box, use a iron wire. Just make a Z of this iron wire and paste a chart paper over it. You need to take care of that. There is a wheel over here. Just find a wheel from market and then paste it here. These are the hollow pipes which you can buy from any soda shop. Then connect it here. Use a wire to connect the lift with the wheel which will used to lift the lift. So that's all about how to create a lift. Now paste a measuring scale on this lift, as you can see, and connect a wire, elastic wire. As you can see, this wire is elastic. You need to place an elastic wire between D and your lift. I am telling you to paste an elastic wire just because if you increase the height of the lift, the hypotenuse will simultaneously increase. So if you use a normal wire, this will create tension between it and your model will break. So take care of that. You need an elastic wire for this, so that this will work. Now as you can see, the difference between the base and the height, lift, is constant. So we have marked a constant distance between the center of the D and the lift. So by using Pythagoras theorem, H equals to under root P square plus B square, where P is height and B is base, we can calculate this hypotenuse.
Hello students, was it okay? Was it interesting? I hope, yeah. In that case, definitely I deserve a thumbs up, isn't it? And how you liked it, please write down in the comment section so that I can modify myself. I can try to bring more, I can modify my videos more and more. I can present it to you in more interesting method or manner. Please like करना और comment section में लिखना how much you liked this video and what was the most important part of this video, and please share this video to your friends as much as possible, and please subscribe the channel. Okay, thank you, good night.